Good afternoon, class. My name is Logan Bueno, and today we will be discussing the module concerning the nature of stars, specifically the Barnard star and the concept of higher proper motion. As always, before we begin this audio lecture, started off with a quote from my favorite movie, The Princess Bride. Wesley says, "Nonsense, you're only saying this because no one ever has." This relates to the discoverer of the Barnard star, Edward Barnard, because no one has ever discovered it before then. Nobody knew it existed. He was the first to discover it. To begin, start by discussing the concept of proper motion. Proper motion is just a fancy term that refers to the angular velocity that a star travels across the night sky in reference to the other celestial bodies behind it. In simpler terms, it is just showing us from our position here on Earth the visible path of the star across the night sky and the speed at which it travels. Therefore, in result with proper motion, we can indicate how relatively close a star is to our solar system. So, when a star has a higher proper motion, or a larger proper motion, it is indicating that that star is a lot closer to the sun than if it were to have a small proper motion. Following the definition of proper motion, this next slide is a perfect transition because it is the greatest example of higher proper motion. For the Barnard star that we are discussing actually has the highest proper motion out of any known star. At a total higher proper motion of 10.39 arcseconds annually, this Barnard star becomes the nearest known single star to the Sun, only after the Alpha Centauri and Proxima Centauri system, but these are not single star systems. In result, the Barnard star is the closest single star to the Sun, and it is approximately about 6 light years away. For my next slide, I will be discussing the properties and characteristics of the Barnard star. To start, it is a main sequence red dwarf star with a surface temperature of about 3100 Kelvin or 2900 Celsius. It is a very faint star with a visual magnitude of 9.5. It cannot be seen with the naked eye. It has an intrinsic luminosity is only about 1 of 2600 of that of the Sun, and about 14% of the Sun's mass. The Barnard star can be seen located in the direction of the constellation Ophiuchus, the Serpent Bearer. In fact, sometimes it is so difficult to locate that NASA has nicknamed it the Great White Whale of star hunting, which is one of its many nicknames. Its other most popular name is the Barnard's Runaway Star, because the proper motion makes it seem like the star is moving extremely fast. A matter of fact, it is the fastest moving star in Earth's skies. It's a fairly recent star, actually. Barnard star just came into our attention barely 100 years ago, and that is because it cannot be seen with the naked eye. So, in result, the ancients, or anyone before the 1800s, had absolutely no idea about its existence. It doesn't figure into the lore of any constellations or cultural tradition, so which makes it absent from all history books or ancient folklore or traditional stories. Any traditional fact. It wasn't even until the late 1800s that the star was discovered, thanks to Edward Emerson Barnard, who was born in 1857, and in 1923, he was an American astronomer whose phenomenally keen eyesight and considerable skill with the telescope led him to becoming the first person to notice and record the Barnard star. And furthermore, he became arguably one of the greatest observers of the last century. Edward first noticed the star while comparing photographs of the same part of the sky taken in 1894 and again in 1916. The star appeared in significantly different positions, which betrayed its rapid motion. And this, in return, allowed them to discover its extreme higher proper motion. This star discovery was very difficult for him to find because of its insanely faint magnitude. With the visual magnitude of only about 9.5, You can't see this with your eyes alone, making Barnard stars only a telescopic object. And since this can't be seen without powerful binoculars or a telescope, finding it requires fields of both experience and perseverance. This concludes my history for the Barnard star. If you have further curiosities, it can best be seen located in the summer evenings of June, July, and August, located near the Serpent Bearer constellation, as we talked about earlier. This brings me to my final slide to wrap up the module and end with discussing the true nature of stars. The nature of stars is a wildly mysterious phenomenon that stretches far across the universe and impacts everything in it, from small and big to living or just existing. Nothing would be here without stars. We owe the existence of the Earth to the Sun, which is a star, and any other possible habitable planet. There'd be no habitable zones without stars. Heat would not exist, therefore life would not exist. Even us humans are made up out of stardust. But strangely enough, these powerful life creators are only created out of helium and hydrogen. That is the true nature of stars. That it is hydrogen fusing with helium through the process known as the proton-proton chain, and in result, a star nuclear core produces light and heat. And for light and heat comes life. So, in other words, the nature of stars is they are a big ball of exploding gas that creates the products necessary for life. To relate to the rest of my group and the processes they're discussing, all have some sort of effect on the nature of stars. For example, the Aney jump cannon is a system to classify stars created by Aney jump cannon to base them off their temperatures. So, based off Aney cannon's classifications, the Barnard star has a spectral class of M4. This system is still used today as the current system of stellar classification. The stars are classified by temperature, ranking from letters O to B, A, F, G, K, or M, O representing the hottest stars and M representing the coolest. The next object of my group is also a diagram that refers to the classification of stars. This is called the Hertzsprung diagram, and this diagram classifies the stars by luminosity, temperature, and mass, putting them into categories to label what kind of star they are, either red dwarfs to red giants, main sequence stars, or white dwarfs. The Barnard star is a main sequence star on the Hertzsprung diagram. Last but not least, we have the Alpha Centauri and Proxima Centauri star system, which is actually the only other star system that's closer to the Sun than the Barnard star, and the closest known non-singular star system. That concludes my discussion of the Barnard star, higher proper motion, and the nature of stars, as far as my other classmates' processes and their relation to the nature of stars. I hope you guys enjoyed, and have a great night.